The first one is coming from the EU University, Muhammad Waseem. He'll be talking about MXene MOF hybrid catalyst for energy efficient applications. Floor is yours.
Thank you. Good morning, everyone. I'm myself, Muhammad Waseem, and I'm recently completed my PhD from UAE University. And the topic I selected for my presentation today is titled as a promising MXene MOF hybrid catalyst for energy efficient amine solvent regeneration. These are the contents of my presentation, and as we know that the CO2 emissions is an emerging concern of our era, and the concentration of CO2 as of 2020 in the atmosphere is 412, which is increased from 280 in 1750. And as of today, when I'm presenting here, this concentration is reached up to 425. So exceeding the limit of 350, which is advised by the environmentalists. So CO2 in the atmosphere is released in two forms, the point sources and non-point sources. The point sources are also called direct sources. For example, from the industrial sources are power plants and fossil fuels emissions, while the non-point sources are indirect sources are kind of portable sources, like from the buildings or transportation. So the capture from the point sources is rather easy as compared to the capture from non-point sources. Just quick recall, there are three major approaches for capturing CO2 post-combustion, in which CO2 is captured after the fuel is burnt, CO2 is captured at later stage, while in pre-combustion, CO2 is captured before burning the fuel, while it is converted into syngas where CO2 is separated and the hydrogen as a clean fuel is used. In oxy-fuel, the flue gas is recirculated while the fuel is burned in the presence of pure oxygen. And as a result, the high concentration stream of CO2 is easy to capture. So then the post-combustion, I'll come to the post-combustion, which is my area. We know that amine-based solutions are used to capture CO2. There is an absorption column in which flue gas has CO2 and the amine solution from the top absorbs CO2 from the flue gas. While that amine solution, after capturing CO2, goes to the stripping column where it is heated at high temperature, and that amine solution is regenerated for reuse. This is a mature technology and is already being applied in industries. So the problem with this amine-based CO2 capture is that the regeneration of amine solution is energy-intensive process, and high temperature is required from 120 to 140 degrees Celsius traditionally to regenerate that solution. And because of this high temperature, thermal degradation of the solvent may happen, and the high capital cost and environmental problems are also there for this traditional amine-based CO2 capture. Now, my work is that when we add a catalyst into the amine solution for the regeneration, that same regeneration which is being done above 100 degrees Celsius can be done below 100 degrees Celsius, while the process becomes energy efficient and it can be carried at low temperatures. We also avoid thermal losses, and it's very selective, low capital cost, obviously environmental friendly process. The mechanism behind this, when CO2 is absorbed using amine solution, it is absorbed in form of carbamate and protonated amines. So if we want to regenerate the solution to get the amine solution back to reuse it, then we need the reverse of this process, which is actually energy intensive process, and it takes energy. So in the presence of the catalyst, while having the catalyst surfaces active sites for the regeneration solution, then we can do this at lower temperature. Just a quick recall of a couple of literature studies. For example, this Bhatti group, they studied different metal oxides, and the vanadium oxide and molybdenum oxide, they are giving the efficient regeneration of amine solution. The more CO2 is being desorbed from the amine solution. And similarly, in another study by Zing group, they made this MOF-based composite catalyst, nanocatalyst, and they are increasing the rate of CO2 desorption by 153% and amount by 64%. So this is a lab scale setup that where we have this amine solution which has CO2 loaded in there, while in the presence of my catalyst, that solution can be regenerated efficiently, and we can increase the overall efficiency of CO2 capture process. I synthesize this catalyst, like first I'm synthesizing the MOF, which I use, then I'm synthesizing the MXene and in situ composite of my catalyst, which I'm using for the regeneration. So as we can see from the figure A, that when this catalyst is present in my amine solution, then the CO2 is being dissolved, and the loading of CO2 in the amine solution is decreased with respect to time. And this is showing the efficacy of my catalyst. And the most efficient one is my composite catalyst, which is having both the MOF and the MXene composite in my catalyst. Then the rate of the catalyst in the second figure is shown. Then we can see that adding each individual catalyst, the rate is being increased and shifted toward the left side, and which is also showing the efficient regeneration process while using my catalyst. And there, the third one graph is showing the amount of CO2 dissolved when we are having no catalyst and we are having our nanocomposite catalyst. Then the more amount of CO2 is dissolved from the amine solution in the presence of the catalyst. And then third one is the cyclic stability study of the catalyst. So obviously the first cycle showed the more efficient regeneration, and we proceeded again for up to 10 cycles. Even the 10th cycle is still showing the 31% more CO2 is dissolved as compared to the non-catalytic process. So there are some characterization of my catalysts. It is showing the successful integration of both of the individual composite into individual in my composite catalysts. So in conclusion, that nanocatalysts can regenerate the amine solution energy efficiently. As a result, we can regenerate amine solution at lower temperatures, which can make the overall process of carbon capture energy efficient, which increase the amount of dissolved CO2 and the rate of regeneration, as well as the heat duty used for the regeneration of amine solution. Thank you.